Yeah, good evening. You studied general purpose implementations. 8 classes completed. What are the classes left? Priority queue. Next one, Arabic. Next, first priority queue. Next one, priority queue. See, priority queue. See, priority queue derived from abstract queue derived from abstract collection and object, that is superclass like that. Here, initial capacity observe 11. See, creates a priority queue with the default initial capacity 11. Okay. Not mentioned means load factor is not mentioned means 100%. Okay. Load factor is 100%. That is load factor and duplicate values, null values, these all you have to remember. So first of all, note down a priority queue is a queue in which elements are inserted. A priority queue is a queue in which elements are inserted at rear end and deleted at front end. A priority queue is a queue in which elements are inserted at rear end and deleted at front end. A priority queue is a queue in which elements are inserted at rear end and deleted at front end. In a priority queue, least element is a highest priority. In a priority queue, least element is a highest priority. It allows duplicate elements. The bit was before that. Here, priorities are compared. Here, priorities are compared by using java.util.comparator interface. Here, priorities are compared by using java.util.comparator interface. About this interface, you'll study next category. You studied already collections, framework collections. How many subcategories are there? 3. What are those? Core collection interfaces, general purpose implementation, more utility collection. The third category, you'll see that one. Third category, I'll explain. Okay. Here priorities are compared by using java.util.comparator interface. It allows duplicate elements. It does not allow null values. It does not allow null values. Initial capacity of priority queue is 11. Load factor of priority queue is 100%. Initial capacity of priority queue is 11. Load factor of priority queue is 100%. Okay. See, while teaching queue and deck differences, diagram also given. Queue diagram. While teaching queue and deck, given. So like that only. It allows duplicate elements. It does not allow null values. Initial capacity of priority queue is 11. Load factor of priority queue is 100%. See, is it over? Actually, internally what it uses is, that is also written. Internally, it uses heap tree data structure. Internally, it uses heap tree data structure. A heap tree is a tree in which each node greater than its child nodes. A heap tree is a tree in which each node greater than its child nodes. So every two child nodes maximum will be heap tree. See, so heap tree construction, it will take more time. That is not required in Java. Suppose here element is 87. Here suppose 34. Suppose it is 31. Now more than this one, if it is there, it is called heap tree. So two child nodes, as compared to two child node, this is greater. So which each node greater than its child nodes. While again here child nodes are there. Here child nodes are there. It should be, this should be greater. Here child nodes are there. This should be greater. That type is there. It is called heap tree. That heap tree construction, this all no one will ask about this. You remember duplicate elements, null values, capacity, initial capacity, load factor. Okay. Now, how to use say. Here method names are somewhat different. Offer, poll methods are there. That is also written otherwise. Here, offer method use it to insert an element, and poll method use it to delete an element. Here, offer method use it to insert an element, and poll method use it to delete an element. Here, offer method use it to insert an element, and poll method use it to delete an element. File, open. See, priority queue, integer, PQ equal to new priority queue. Now PQ dot offer, inserting. PQ dot offer, inserting. PQ dot offer, inserting. System dot out dot println PQ. See here, insertion order not preserved. That is also written. Here, insertion order is not preserved. That means my order not maintained. Another order comes. Internal data structure. Here insertion order is not preserved. Here insertion order is not preserved. See, if I run file, save. This output also you cannot predict. But one element you can predict. Least element, highest priority. That will come first. So in all elements, which is list? 43 first element. But is it ascending order? No. Is it descending order? No. That is heap tree order. That's what it comes like this. When you remove, again in this which is list? 54. That will come first. It is changed, position changed again. Say system dot out dot println PQ dot poll. One element deleted. Again I'll print. That orders may be changed. Again I'll delete. PQ dot poll. Again I'll print. Again I'll delete. See, all list elements only comes out first. That is called priority. Compilation, execution. Sorry. See, here which is list element? 43. 43 came out. Again which is list element? 54. See, that will come first. Here 54 came out. Which is list element? 55. That will come first. That is deleted. Here again which is list element? So 55. That 55 come out. 71. You observe while printing also here this is list. Okay. In this which is list? 54. That it came first. In this which is list? 55. That it came first. In this which is list? 71. But here you observe positions changed. Okay. Write this one. Over. So Q diagram already explained. Front side deleted, rear side inserted. Okay. This output node. This output we cannot predict, but only one element we can predict. Whichever is least, that will be first. In all elements, 43 least. That is 43 first. Remaining elements, 54 least. 54 first comes. In remaining elements, 55 least. That will come first. Remaining elements, 71 first. That will come first. Output we cannot predict. Insertion order is not preserved. Heap tree construction, 10 diagrams comes. For every element, one diagram. That type will be there. So here remember, only least element is highest priority. Like that works. You have seen like this. This is front end. This is rear end. Here insert, here delete. That is Q diagram. Deck diagram, both side inserting possible, both side deleting possible. That is deck diagram. This is all already explained. Comparisons, everything again. This is about priority queue. Next one. This output also no need to write because no use. Only least element only we can remember. Now, next one, array deck. It is an implementation of double-ended queue. It is an implementation of double-ended queue data structure with array representation. It is an implementation of double-ended queue data structure with array representation. It allows both insertion and deletion at both the ends. Rear end and front end. Because it implements deck interface. It allows both insertion and deletion at both the ends, rear end and front end, because it implements deck interface. It allows duplicate elements. It does not allow null values. It allows both insertion and deletion at both the ends because it implements deck interface. Yeah, that's what method names will be: add first, add last, remove first, remove last. In between we cannot remove. In between we cannot add. So deck interface you studied, no? front end, rear end, both side inserting, both side deleting. Front end, rear end. Like insert, insert, delete, delete. Both side inserting possible, both side deleting possible. That is called deck interface diagram. Queue and deck difference given. Now methods you observe. The diagram already written. See, array deck. Here methods. See, add first, add last. Get first, get last. Remove first, remove last. That will be there. Initial capacity 16. But here load factor not there. Load factor not mentioned means by default 100%. Okay. Now node on. Initial capacity of array deck is 16. Load factor of array deck is 100%. After filling, then allocates. But initial capacity, default initial capacity, you can specify the capacity also. That separate constructors are there, no? So by default 16. That is, you can change. See. Say array deck integer AD equal to new array deck. AD dot add one element. Now you can insert at the beginning also, ending also. So add first if you write before 83 added. Add last if you write after 83 added. Again add first, like that, whatever you want you can write. Duplicate also allowed, but null values not allowed. If you write like this, you observe what will happen. First 83 added. 83 added. After add 83, add first 71. So 71 added. Add last 78. Add last 73. Add first 73. Add last 99. So what will happen, see here, this output comes. If you want to delete, what we can delete? 73 can be deleted. Other elements cannot be deleted. After deleting these two only, other. Again these two. Like that. See? File, save. $73, $71, $83. See, whatever I given my order. So insertion order is preserved. Here insertion order is preserved. Whatever you are specifying, that order maintained. Maintained means preserved. Here insertion order is preserved. Now write this program. Is it over? Up to here, general purpose implementations completed. Okay. Java.util package classes and this output also not done. This order is preserved. Just a remove method if you call deleted, that's it. Any difficulty is there to understand this program? Nothing. 83 added. Add first means before added. Add last means last added. Again add last. Add first. Add last. Remove if you call, remove first means first side removed. First one removed. Remove last means last is removed. That's it. Okay. Now, next java.util package class and interface. How many categories divided? Java.util package class and interfaces, 2 categories divided. What are those? Collections, framework collections, Legacy collection. Collection framework collection. How many subcategories divided? 3. What are those? Core collection interfaces, general purpose implementation, more utility collection. So 2 categories completed. Next, more utility collections. First one, more utility collections. First one, iterator. It's an interface. Second one, list iterator. It is also interface. Third one, map.entry. Here, entry is an inner interface of map interface. Here, entry is an inner interface of map interface. So, iterator is interface. List iterator is interface. Map.entry. Here, entry is an inner interface of map interface. Scanner class. Arrays class. Collections class. Comparator interface. Iterator interface, list iterator interface, map.entry, scanner, arrays, collections, comparator. Is it over? First one, iterator. It is used to iterate elements of a collection. It is used to iterate elements of a collection. It is used to iterate elements of a collection. How to iterate? I'll show you. Say, you are getting output like this. You are getting output like this. One element, if you want to iterate, this is required. See, for example, I'll go for array list. Array list integer al equal to new array list. al dot add. al dot add. al dot add. Like this, array list we created. We printed like this. See, actually, for a graphical, for operator point of view, graphical user interface will be there. Suppose assume these are student marks. Data entry operator, he will enter. He'll enter hall ticket number, name of the candidate, like that, marks. He'll enter hall ticket number, name, marks. He'll click submit button. This element added. One more marks. Again, this element added. One more marks added. If you display, all will be displayed. But data entry is finished. Assume later university decided to add 5 bonus marks, but already entry completed. Everything is completed. Thousands of people data entered already, but later they added 5 bonus marks. Then what we have to do in this situation? Just one more graphical user interface, something bonus marks. Bonus marks. Here you will enter 5 bonus marks. You will click submit button. Just here type 5. You will click submit button. Then it will be added to all students. How? Backside code we are to write. That code only we are going to write with iterator. Suppose if I write AL plus 5, error comes because it contains hash code. Hash code plus 5 means error comes. See, file, save. See, error. So we cannot add, but this entry is completed. But I want to add 5 bonus marks. Then what we can do? From this array list, one element we have to iterate. After that, plus 5. How to iterate? Library is there. Java P, java.util.iterator. Here methods are there. Methods. No done. It returns true if the element is present. Otherwise, returns false. It returns true if the element is present. Otherwise, returns false. It returns current element and moves a cursor to next element. It removes current element. It returns true if the element is present. Otherwise, returns false. It returns current element and moves a cursor to next element. So has next method, it returns true if the element is present, otherwise returns false. So it is going to return true or false. It returns current element and moves the cursor to next element. Next method if you call. Remove method if you call, it removes. Suppose actually elements are like this. Like this we have. Cursor is here. Cursor is here. If I call has next method, what it returns? It returns true if the element is present, otherwise returns false. Now has next method if I call, it returns true. Now if I call has next method, it returns true. If I call next method, it returns current element and moves the cursor to next element. So what is returned? 23 returned. Cursor moved to 45. Okay. Again as next. Again as next. True. Next. 45 returned. Cursor moved to 29. Again as next. 20. True. Next. Like this it will move. Now this 23 comes now plus 5. You can add. 45 comes now plus 5. You can add. So 1 we can iterate, we can add. That purpose this interface required. Okay. So has next if you call, true comes. Next if you call, current element comes. Like this, after moving here, again as next if I call, false. Until you get a false, call these methods. Once false comes, you stop. Okay. See once again. Now here I given how many elements are there? 5 elements. These 5 elements are there. Cursor is here. Has next. True or false? True. Next if I call, 78 return. 78 plus 5. 5 bonus marks you can add. Cursor comes here. Again as next. True. Next if I call, 74 comes plus 5 bonus marks you can add. Cursor comes here. Has next. True. Next. 46. This 46 comes plus 5 you can add. Cursor comes here. Has next. True. Next. 78 comes plus 5 you can add. Again as next. True. Like this. After this, again has next. False. You have to stop. So until you get a false, move the cursor. Once false comes, we have to stop. Then which loop required? Which loop? While loop. If number of iterations we do not know, while loop. Number of iterations if you know, for loop. Here how many elements are there? Now 5 is there, okay. Thousands will be there. We cannot predict. That's what while loop. What we can do here, while. Here has next method returning true or false, no? But here you have to call has next. But has next method in which interface? Iterator. It is interface. It is abstract method. But it is already implemented. No need to implement. But iterator reference required, no? It is instance method or class method? Instance method. Iterator reference required, no? Which collection we are using? Array list. In that class, we have to search. In this class, we have to search. See here. If we call this method, you'll get a reference. Write it. It returns iterator reference. It returns iterator reference. Is it over? Now, is it instance method or class method? How many ways to access? What are those? Which class object required? Array list. What is the return type? Iterator. So here. Now, for calling this method, array list object required. Already we created. That object reference is AL. With AL, can I call? What is the return type? Iterator. So iterator E nothing but integer. I equal to AL dot iterator. This line. First, is it clear this line? See? Here. Iterator is a method. With array list reference, I am calling AL dot iterator. Return type iterator. So, return type iterator. E nothing but integer. I equal to AL dot iterator. With this I, can I call has next method? Yes. I dot has next. Okay. Here. Next method we have to call. Next method. What it returns? E nothing but integer. Int x equal to I dot next. Actually, E nothing but integer. Integer assigned to int. What is this? Auto unboxing. Integer assigned to int. Auto unboxing. After this, system dot out dot println x plus 5. 5 bonus marks added. For every student added. See, first what will happen? See, first what will happen? Just observe here. Like this, 5 elements. See, 5 elements memory allocated. Array list is 10 elements allocated, but just I am writing 5. It is 0, 1, 2, 3, 4. that is not required also present. Now 78, 74, 46, 78 plus 66. Now, first of all, array list created, these 5 elements added. If you print like this printed, now iterator reference comes. I dot has next, cursor is here. True or false? True. I dot next, what is written? 78. 78 written. Then 78 plus 5, output comes 83. Again, cursor moved here. Cursor moved. Again as next. True or false? True. Next. 74 written. 74 written. 74 plus 5. 79. Cursor moved here. Again, this is rotated. No? Again has next. True. Next. 46. 46 written. Okay. 46 plus 5. 51 printed. After that, cursor moved here. Again as next. True. Next. 78 written. 78 plus 5 printed. 83. Cursor moved here. Again as next. True. Next. This 66 written plus 5 added. 71 printed. Okay. Again as next. Cursor moved here. Again as next. Stop it. This output comes. Clear? Write this one. Like this iterated. Import the package also. Import java.util. It is there. So one element iterated with iterator. So starting they used it like this, but later enhanced for loop came. No, it is very simple as compared to these all. Enhanced for loop very simple. No, first is it over? Because enhanced for loop later 1.5 version came. Previously like this. Is it over? No done. Elements can be iterated. No done. Elements of a collection can also be iterated with enhanced for loop. Elements of a collection can also be iterated with enhanced for loop. Elements of a collection can also be iterated with enhanced for loop. Example. Just for integer x colon al. System dot out dot println x plus 5. It is very simple. See, file, save, compilation, execution. See, iterated. Write this one. Example. So with enhanced for loop also we can iterate. As compared to that, it is very simple. Okay. We'll see continuation tomorrow.